application of differentiation.
So first, this is our learning targets for this video. First, we're going to learn what is the meaning of the differentiation. Second, we define the related rates. Third, why we need to use related rates. And lastly, how we use derivative to solve related rates problem.
For the introduction, we are going to talk about what is differentiation, what is related rate, and why we use related rates. What is differentiation? Differentiation is a method of finding the derivative of a function. Differentiation is a process in math where we find the instantaneous rate of change in function based on one of its variables. The most common example is the rate change of displacement with respect to time, called velocity. The opposite of finding a derivative is anti-differentiation. If x a variable and y is another variable, then the rate of change of x with respect to y is given by dy dx. This is the general expression of the derivative of a function and is represented as f prime x equal to dy dx, where y equal to fx is any function. What is related rate? Related rates and problems involving related rates take advantage of quantities that are related to each other. Related rate help us to determine how fast or how slow a certain quantity is changing using the rate of change of the second quantity. Let's look at the example shown below.
Hello everyone, this is Ahmad's story.
Okay, class. Today, we're going to learn about application of differentiation.
I feel so exhausted. Let's buy some drinks. I wonder what is the surface area of this tin?
What is the surface area of the tin cans?
Huh? Is that true?
Show that the volume of water is given by 5 pi r cubed.
Wait a second. It says that this tin can is 15 centimeters high. So, let's say that I drink the water at the rate of 10 centimeters cubed per second. Then, how fast is the depth of water will decrease when water is 14 centimeters deep?
What if Ahmad drinks the water at the rate of 10 centimeters cubed per second? How fast is the depth of water decreasing when the water is 14 centimeters deep?
Why we use related rates? We use related rates because of related rates can help us to determine how fast or slow a certain quantity is changing using the rate of change of another related quantity. In addition, related rate can show us to determine the changing volume of water before and after. Overall, related rates is very suitable for our group topic, which is we want to solve the problem about the cans.
Based on our videos, the problem statement that we define, first, what is the surface area of the beverage cans? Second question is about show that the volume of water inside the cans is given by 5 pi r cubed. And last, if Ahmad drinks the water at a rate of 10 centimeter cube per second, how fast is the depth of the water decreasing when the water is 14 centimeter deep?
So, for the first problem solution, what is the surface area of beverage cans? So, given that radius of can is 3 cm and height of the can is 15 cm, A equals to 2 pi r square plus 2 pi r h. A equals to 2 pi multiplied by 3 square plus 2 pi multiplied by 3 multiplied by 15. So, 18 pi plus 90 pi, A equals to 108 pi.
Okay, for the question 2 need to show that the volume of water inside the cans is given by 5 pi r cube. Given that the radius of cans is 3 cm and the height of cans is 15 cm, so the volume of cans is cylinder, so the volume of cans is pi r square h. So first of all, we have to find the h, so we will make as r over 3 equal to h over 15. We will get h equal to r over 3 times 15, and the h we will get h equal to 5r. And based on the formula of cylinder before, volume equal to pi r square h, and we will make h in term of r, so volume equal to pi r square times 5r, and the final answer we will get 5 pi r cube.
Okay, next. The third question is, if Ahmad drinks the water at a rate of 10 centimeter cube per second, how fast is the depth of the water decreasing when the water is 14 centimeter deep? So, if Ahmad drinks the water at a rate of 10 centimeter cube per second, is a dV over dt. So, from the question, we can conclude that water height is 14 centimeter and dV over dt is negative 10 centimeter cube per second. Why is the dV over dt is negative? Is because Ahmad drinks the water, so the water will decrease. So it is a negative sign. Okay, so first we have to find the r in terms of h, because we only need one variable in one question. So r is r over r divided by 3 is equal to h divided by 15. 3 and 15 we can see at the question given, because the bottle of the beverage cans, the radius is 3 and the height is 15. So r divided by 3 is equal to h divided by 15. And from that, we can get the r is equal to h over 15 is multiplied by 3. So the answer is r equals to h divided by 5. So from r, we can insert the value of r inside the formula of volume, which is volume is equal to pi r squared multiplied by height h. So we insert the value r in terms of h. So from the question, the answer is volume is equal to pi over 25 multiplied by h cube. So now we get the value of the volume, so we can differentiate the volume. It is dV over dt equals to pi over 25. We differentiate h cube is equal to 3h squared dh dt, and then we get 588 over 25 pi dh dt. So now we can we done doing the differentiate part, so we can insert the value of dV over dt, which is negative 10 centimeter cube per second. So 588 over 25 pi, dH over dt is equal to 10 negative 10. We make the dH over dt as the variable, as the subject, and then negative 10 multiplied by 25 over 588 pi is equal to negative 125 over 294 pi. So we can conclude that the depth is decreasing at a rate of 100 to 25 over 294 pi centimeter per cube.
This learning leads to several important conclusions. First, understanding rates of change. Differentiation allows us to precisely quantify how quantities change in relation to each other, providing insight into rates of change at specific points or intervals. Second, real-world application. These concepts are useful for solving real-life problems where many things change at once. Techniques like the chain rule and implicit differentiation help us figure out how one change affects another in practical situations. Third, improving problem-solving skills. Mastering these ideas improves our ability to solve problems by analyzing how different things relate and using MAT to find unknown rates. It helps us understand relationships better and apply maths in useful ways.